Hi, I'm Greg from Emesent. Today in this video I'm going to show you how you can use PPK or post-process kinematic to georeference and correct your hover map scan. PPK lets you accurately georeference your scan in the real world without relying on communication on site to receive real-time corrections. So that could be self-service for end-trip corrections, or having a base station within close range, or getting good line of sight to a local base. All of this means you can have greater confidence and greater flexibility whilst doing projects, especially on remote locations. There are three main steps to PPK which we're going to cover in this video. One is capturing the data and recording RINEX files. Two is processing the RINEX files. And three is processing the scan data. Today we're going to be doing some bridge scanning. We're going to capture the pedestrian bridge with the backpack RTK kit and the vehicle bridge with the vehicle RTK kit. Okay, let's get started. To use PPK, you'll need your hovermap STX paired with either the backpack RTK kit or the vehicle RTK kit, and you'll need a supported GNSS receiver. We're using the Emesent RS2 Plus as a rover on the backpack, and we're using the RS3 on the base, which is set up over a known coordinate. Before you start your hovermap scan, it's important that you're logging RINEX files on both the rover receiver and the base receiver. So to do that, I'm going to go into the Emesent Flow app and start logging RINEX on both receivers. So I'm going to go into my rover first. I'm going to go into logging, and then I'm going to press start recording. Now I'm going to go into the base receiver, go into logging, and start recording. Okay, now I'm ready to capture my hovermap scan. Today we're going to be using PPK to do some bridge scanning. We're going to capture the pedestrian bridge here with the backpack kit and the vehicle bridge with the vehicle kit. So first we're going to do the pedestrian bridge. So I've got my Commander app open on my tablet. I'm going to do a non-autonomous mapping mission. I'm going to go through and complete my pre-mission checks. I'm going to connect to the hovermap via Wi-Fi. And here I have the option to use PPK in the scan, which I'm going to enable. And now Commander's giving me a reminder to ensure that RINEX is logging on my receivers, which I know it is. So I'm going to check that. I'm going to hit continue. I'm going to name my scan, and then I'm going to start my scan. Okay, hovermap's now ready, so I'm going to go scan the bridge. Okay, we've finished capturing the pedestrian bridge, so I'm going to stop the scan in Commander. Next, I want to capture this vehicle bridge as there's no pedestrian access to it. I'm going to use the vehicle RTK kit for that. Important to note that we don't have to stop our RINEX logging on the receivers. We can use the same RINEX log for both scans. So I've got the vehicle RTK kit set up on the vehicle now, and we're going to go and capture the vehicle bridge. We've now finished capturing the two scans, and I've stopped logging RINEX on both the base and the rover. So now we're going to head back to the office to process the data. We're now back in the office and we've offloaded our data. So we've got the two hovermap scans, the pedestrian and the vehicle one. And we've also got the base and rover RINEX files. They are offloaded as a zip file, so I've just extracted those so that we can use them for processing. So we're going to be using Emesent Studio to post-process the RINEX files, which is a free app available on the Emesent website. So I'm now in Emesent Studio, and we're going to select the Kinematic processing option. And the first step is to upload the rover observation file. So I'm going to go into my rover RINEX folder and find the observation file, which is the one that ends in .260. Now we want to update the rover antenna height to not use an antenna height, because we don't have an antenna height when we're using the hover map with the rover. We now want to select our base observation file. So I'm going to go into the base RINEX folder and select the base observation file. The RINEX header position will be selected by default, but we set this base up over a known coordinate, so we want to enter in that known coordinate so we get the best possible result.
So this coordinate I've already entered before, so it's already populated, but you'll need to enter that in based on where you set up your base. We need to check and update the base height if we need to. My base was set up at 2 meters, so that's correct, so I'm not going to change that. And lastly, we need to upload the navigation file. So you can upload either the base or the rover navigation file, which is the file that ends in .26p. So now we've uploaded all the files we need for processing. The last step is to check and update the processing settings. So from the default settings, there's two settings that are definitely worth changing. The first one is the filter type, change to combine. That will process the trajectory in both directions to get the best possible fix percentage. And we also need to change the time format because we're going to be using UTC time. So when we're first processing the data, typically we will start with just those two changes and leave the rest of the settings on default. But it's worth noting that it can be beneficial to change a number of these settings on screen, and it's worth looking at more information on this in our knowledge base. So I'm going to save that. I'm now going to click Process to start processing the RINEX files. Great, so my processing is now done. I can see the trajectory that was used for the capture and the fix percentage down the bottom. So I've got 96.8% fix and 3.2% float. You can click this little base button here to show where the base station was set up, which can be handy to review the scan. I can now go to show result files. So this is going to show me the georeference trajectory, which is a .pos file that was created from the RINEX processing. So this .pos file is important because this is the file that I'll need to process the scan data in Aura, which is the next step. It's important not to use the underscore events.pos file. That file won't be helpful for processing in Aura. Before we finish in Emesent Studio, it also may be helpful when reviewing your data to look at the RTK outcome for the same capture as well. So you can actually, if I go back to my rover RINEX files, I can open up the .llh file in Emesent Studio. And this is a file which contains all of the positions and quality metrics for the RTK scan. And this can be helpful to do a comparison of your RTK capture versus your PPK processed files. So you can see in this case, the RTK result for this particular scan and location was not as great fix percentage as the PPK result. So we're now going to move over to processing the scan data in Aura. We're now in Aura and ready to process the scan data. So we're going to go into Process Scan and choose the SLAM RTK PPK option and add our scan dataset. Going to select the pedestrian scan. We can see here the RTK backpack mount has been detected, but we're not going to use RTK. We want to use PPK for this scan. So we're going to go into Processing Settings, and under georeferencing mode, we're going to select PPK backpack mount. And we want to check or update our GNSS receiver type. So for us, we've got the MLID here, which is correct. We want to enter in our base coordinate reference system. And we're going to reproject this data set. So we're going to enter in our target, horizontal, and vertical CRS. Going to click Save. You can see here it's telling me that PPK processing is now on, and I need to upload my .pos trajectory file before I can start processing. So I'm going to click Add PPK Trajectory, and I'm going to go into my rover RINEX folder, which is where the .pos trajectory file output from Emesent Studio was saved. I'm going to select the .pos trajectory file. Aura will now validate that that's a correct trajectory file and that it has sufficient time overlap with the scan. Now that's validated, I can update my output name and start processing. Now our processing job is complete. We see we have some output files. We have full resolution point cloud, subsampled point cloud, trajectory, which is in the target CRS, and a trajectory which is not reprojected. And then we have our fit metrics or accuracy report. So I'm going to open up the subsampled point cloud. And then while that's opening, we can have a look at the accuracy report. So this is the PPK accuracy report. So at the top we can see the fix percentage for the GNSS data. For this scan we had fix almost 99% of the time. And then on the second table there we can see the accuracy reported by the receiver. So we can see we had a horizontal RMS of 16 mil and vertical RMS of 28 millimeters. And then at the bottom table we can see the reported error distance between the GNSS trajectory and the SLAM trajectory. So we had a horizontal RMS of 36 millimeters and vertical RMS of 32 millimeters. Now that my point cloud is open, I'm just going to adjust the intensity color scale so we can see point cloud with a little bit more definition. And I might also open the trajectory so we can view that alongside the point cloud so we have context as to where the scan took place. Great, so we can see where the backpack scan took place, around near where the base was set up was where it kind of started and finished. And then we went across this pedestrian bridge here, and then down the end to the other side of the bridge, and then returned back. We can see here we captured a little bit of the vehicle bridge in our backpack scan. So what we would do next is process the second scan, and we can follow the same workflow that we did for the first scan. Thanks for watching this video. If you want to learn more about PPK, HoverMap or Aura, please visit the Emesent website.